Alright, so I'm going over the homework, which was page 93, 94 even. The homework was page 93, 94 even. The derivative of number 2 is just 1. The derivative of x is 1. Number 4. First thing you want to do with this is rewrite it. So that's 8/3 x to the negative 2. Right? You can't take the derivative with the variable in the denominator. You want to rewrite it with the negative exponent and then take the derivative. So the derivative is negative 16/3 x to the negative 3. And for last night's homework, that is perfectly fine with me. You can just leave it like that.
Would the x to the negative third technically be the numerator?
If you want to rewrite it, currently it's in the numerator. If you want to rewrite it with a positive exponent, it will go to the denominator and become positive exponent. Like,
why is it not 8/6x?
because you're not multiplying. First of all, you have to rewrite it like this. If that's the case, then you're multiplying 8/3 by negative 2.
So if you have a fraction, you get rid of the fraction first?
Yes. Okay, so don't leave it in fraction form. The power rule does not apply to this. The power rule has to be in the numerator. Number 6. Here I'm going to simplify first. So this is algebra. X to the 3/2 divided by x is x to the 1/2. You're subtracting the exponents. 3/2 minus 1 is 1/2. Now you take the derivative. So 1/2 of 6 is 3. Subtract 1 from the exponent. So it's negative 1/2. 1/2 minus 1 is negative 1/2.
So is that?
Go ahead.
Okay.
So if you want to simplify that, for last night's homework, that was adequate. If you left it like that, that's fine. But if you were taking a test or something, you might have to be rewrite it as 3 over square root of x.
Why
Go
is
ahead.
it to the 1/2?
So wouldn't 3... So can you explain how you divided the x into 6? Like
Okay.
the first step.
So the question is, what did I do with the algebra? So that's an algebra step, okay? Let's do that here. So the question is, how did I get from 6x to the 1/2 over x into what I got? No, I'm sorry, it's a 3/2. So remember, whenever you're dealing with bases with exponents and you're dividing, you subtract the exponents. So this becomes 6x to the 3/2 minus 1. And 3/2 minus 1, well, let's find the common denominator. 1 is 2 over 2. So 3 minus 2 is 1. So it's 1/2. That's how I got it. Okay, so there's number 6. That's the derivative of number 6. This step here is only an algebra step. That is not a calculus step. The calculus step went from here to here. What you will find, most of the problems you're going to be encountering is not the calculus, it's going to be the algebra that's going to give you difficulties. Okay, mostly because I assume you know the algebra. Okay, so, but I welcome those questions. If you have problems with the algebra, ask me those questions. You notice I will answer your algebra questions, but I will still assume that you know the algebra. Okay? Alright, continuing. Number 8. So here, I'm going to have to go ahead and divide that out. So this is an algebra step. This is not a calculus step. I'm dividing each one separately, right? X squared divided by 2x. That's going to be 1/2 x. Right? I would like, this is the same thing as x over 2, but I prefer it as the coefficient. And the next one, that's going to be minus 3. 6x divided by 2x is 3. And the last one is going to be x to the negative 1. Right? 2 over 2x, the 2's reduced, you get x to the negative 1. Right? 2 over 2x is the same as 1 over x. 1 over x is the same as x to the negative 1. Now I'll take the derivative. Derivative of 1/2 x is 1/2. Derivative of minus 3 is 0 because it's a constant. And then the derivative of x to the negative 1 is minus x to the negative 2. And you can leave it like that or change it to positive exponents. That'll be 1 over x squared. Nothing else changes. Yes?
Why are we subtracting the x minus the negatives?
Okay, what the exponent here is negative 1, so that comes down. That's why it turns into a minus.
So if x to the 1 is 1, y is negative 1,
or x to the -1, negative x minus.
Okay? So his question is, if the derivative of x, if I have y equals x, the derivative of x is 1. He's asking if it's -1, why is it negative x to the -2? Right? That's your question?
Yeah.
Okay. So what is the exponent of x here?
1.
1. Alright, so you bring 1 down, so that's the 1, and you subtract 1 from the exponent, so that's 0. Yeah?
Okay.
What is x to the 0 power?
0.
1.
1. Right.
X to the 0 power is 1. So it's 1 times 1 or just 1. Now let's do the y equals x to the -1. You bring down the exponent, so it's -1x. Subtract 1 from the exponent, so it's -1 minus 1 makes it -2. So, but I don't bother to write -1, I just write negative x to the -2. Does that answer your question?
Yeah.
Alright. Alright, number 10. Okay, so this is just straightforward one. You're just going to find the derivative separately. The derivative of x to the 4 is 4x cubed. Derivative of minus 3 halves x cubed is minus 9 halves x squared. Derivative of 5x squared is 10x. Derivative of minus 6x is minus 6. That's it. There was no algebra involved in that one. Number 11, there's algebra involved here. We haven't learned a rule for products yet. So
We do. That's all.
11.
my bad. Number 12. So more algebra first. Go ahead and, is that to the third power?
Yeah.
I am so sorry. Alright. So to the third power is going to be x cubed minus 3 times 2 x squared plus 3 times 4 is 12x minus 8. You're not required to do that in your head. Okay? If you want to do it longhand, well, you'd have to do it longhand if you can't do it in your head. So just do x minus 2 times x minus 2 times x minus 2. Okay? Good news, you'll eventually learn the way to avoid doing that multiplication, and it's only a couple days away. Alright. So y prime is 3x squared minus 12x plus 12. And that's why Dr. Coleman wanted you to know chain rule, Blake, for this problem. Because this is a whole lot easier with chain rule than doing that algebra. Alright, number 14.
Did you explain something to me, Emily? Why did it go to never mind?
You good? Number 14. So we already did it again. Alright. So yeah, this one is easier. Actually, this one might be easier you doing the algebra instead of.
Can you do the question?
No, never mind. I don't know. If you skip this one because you didn't want to do the algebra, I wouldn't blame you. Because I don't want to do the algebra.
Yeah.
Alright. Because I can't do that algebra in my head.
Really?
Alright. So let's do it. What was it? X squared minus x plus 2. Was that it?
Yeah.
Okay, to the second power. So you're going to multiply that by itself. So that's going to be, you want to go left to right or right to left? Left to right. So x to the 4th minus x cubed plus 2x squared. Now the negative x, so it's negative x cubed plus x squared minus 2x. Right, so I'm doing long multiplication. Now finally the 2x squared, 2x squared minus 2x plus 4.
Is there any shortcut for that at all? It's worth learning.
If I knew of a shortcut, I would have tried it.
Okay.
Minus 2x cubed plus 5x squared minus 4x plus 4. Well, the good news is, once we get to the higher techniques and derivatives, you wouldn't have to go through this.
Okay.
We're gonna have to do
But to be honest, I'm not sure that rule is any better.
What the question rule?
Well, that was a combination of quotient and chain rule.
Alright.
Alright, so here I have this, and remember the denominator was x. So let's go ahead and simplify that before we flip over. So divide that by x, that gives you, well, I guess it's easy. You just subtract 1 from the exponent. So this is what we want to take the derivative of, which is x cubed minus 2x squared plus 5x minus 4. That comes from this minus 4. And then 4 over x is 4x to the negative 1. So this is what we want to take the derivative of. Okay, I'm going to go ahead and copy that over to the other side. That's y equals x cubed minus, I already forgot, 2x squared plus 5x minus 4. And what's the last one? Plus 4x to the negative 1.
Yeah.
Alright, now take the derivative. So y prime is 3x squared minus 4x plus 5. The derivative of 4 is 0. So it's minus 4x to the negative 2. And at this point, if you get tired of doing this problem, I quit. So I'm quitting. Alright. Ready?
Ready?
I mean, you could rewrite the x to the negative 2 as 4 over x squared. No, it's going to work. Alright. We're still doing evens. 16. Find the equation of the tangent line to the graph, and then graph the function and the tangent line. Just to let you know, if you did the problems from the front, I gave you full credit. If you didn't turn, because I didn't check anybody's back paper. 'Cause if I were a student, I would skip this problem. All right, because graphing that, anybody know how to graph that without a calculator?
No.
Yeah, so I wouldn't. I'd graph it with a calculator. All right,
It's some sort of weird parabola thing.
is it?
Yeah, it's a
Yeah.
parabola.
Is it a parabola?
Yeah,
Really?
it was that goes like.
Oh, the highest
it's a cubic
It-
function.
Next to the floor.
Not a cubic.
So I
Okay. All right. Well, I'm gonna do some weird algebra because something just occurred to me. Did it work? No, that doesn't work. Never mind.
No, I know you're thinking it doesn't work.
Really?
Yeah.
What?
Okay, now you challenge me.
No, I was just kidding. I have no idea what you're thinking.
All right, I'm gonna go x to the 4th minus x squared minus 2x squared plus 2.
Oh, I get it.
I get it. I
That becomes x squared times x squared minus 1 minus 2 times x squared minus 1. Right?
Then you have to do the squares.
So I got x squared minus 2 times x squared minus 1.
Right.
Where did you get from step the original problem? to the first step?
Well, what I did was I looked at this and I noticed that I can get a 2 there. If I split up the minus 3 into minus 1 and minus 2.
Oh, so you kind of had.
I actually got an answer that was really
Right.
close to that.
And the reason why I did that is because I want to see where the zeros were. So there's a 0 at plus or minus 1 and plus or minus square root of 2. So this is not a parabola. This is like a W.
That's what I said. There's no way.
Yeah, it's not.
I'm
looking at it.
Right. So there's a 0 at negative 1, positive 1, negative square root of 2, which is about here, and positive square root of 2, which is about here.
I said it did the weird thing.
And its a leading coefficient is positive. Okay, let's plug in the 1, 0. Or where's the 1, 0? 1, 0. Oh, it's right here. Duh. Okay. So it's going to look like, so this is a sketch, and let's draw the tangent line first, because then I can match the sketch to the tangent line. All right. So take the derivative of that. Go back to the original to take the derivative. So that'd be f prime of x equals 4x cubed minus 6x. Plug in 1, right? So f prime of 1 equals negative 2. You agree with that?
I agree with that.
All right, so then the slope is negative 2. Slope is negative 2 at 1. So negative 2, so it's going to be downwards, right? So that makes sense. So I'm going to draw like this. Right? That has a slope of negative 2.
Definitely a parabola. Looks just like one.
That was without a calculator.
So easy. Right. Looks exactly like one.
Congratulations.
Did you factor that though without doing the grouping technique?
I don't know how. Oh, you can do a synthetic division.
Wait, but what if, like, how do you know how high the minimum and maximums are?
I don't.
Is there like a way to find that somehow?
Yes. So his question was, is there a way to know how low or how high the mins and maxes are? And the answer is yes, and that is coming up. Well, wait, let me ask you this. What is the slope of the tangent lines at these maxes and mins?
The same.
-2.
They're not all negative too, are they?
They're zeros, right?
So,
At the
Yeah,
maxes and mins,
they're all
the
zeros.
tangent lines are horizontal.
Yeah.
So you set the derivative equals 0, and that'll give you the x values where they're maxes and mins, right? And then you plug in the x values, and that tells you how high or how low they are.
Yeah.
So you already know how.
That's pretty simple.
Yes.
I knew it would have been.
That's actually a simple. Well,
It's easier than I thought.
it's not a simple topic, but it's not that difficult. All right. Anyways, moving on, because it says find the equation of the tangent line, right?
Right.
All right. So we have the slope is -2.
-2,
So we have the point is 1, 0.
1, 0.
Echo. Alright. So this is going to be y minus 0 equals -2 times x plus, or minus 1 rather. You can clean that up a little bit. Y equals -2x plus 2. So, ooh, look, that's really close. And that was just estimate. Pat it back.
So it's our final answer.
Final answer. So there's the equation of the tangent line, and there's the graph. But you don't have to graph this one this way, okay? Graphing using a graphing calculator is perfectly legit. Nothing wrong with that. And it probably looks better than mine. All right.
I thought the tangent line was the derivative.
No. You need a derivative to find the slope of the tangent line. Yeah.
So, like, to find the slope, you find the derivative and then plug the x value in for your point that you
Correct.
already have to find the slope, and then you go to that point and just make the slope.
No. Not make. You mean make the equation of the line?
Yeah, like, you
Yeah.
follow the
You
slope.
make the equation of the line using the slope you found and the coordinates given,
Okay.
or the coordinates you have to find.
Okay.
All right. Ready for 18?
Yes.
So that was 16. Would you be asked to do something like this on an AP test? Something similar. So they will give you a equation, a function, a point, and they'll give you sketches of a diagram and say which one will be the appropriate diagram for a tangent line at that point.
are we gonna have a calculator?
For that problem, probably not. Because that would be trivial with the calculator. Well, maybe not. I don't know. All right, 18. If the slope is something nasty, like square root of 2 over 2, then they will let you use a calculator. All right, let's see. Determine the points, if any, at which the graph of the function has a horizontal tangent line. All right, so you take the derivative. So it's 3x squared minus 3. Set that equal to 0. So factor out the 3, you get x squared minus 1 equals 0. So you get x equals plus or minus 1. Only thing you got to do is make sure that these numbers are in the domain. And, well, polynomial, all real numbers domain. So the answer's right there. X equals plus or minus 1.
That was it?
And that's it. That's all you have to do. You don't have to explain anything else. Even on an AP test, when they just ask for when is a horizontal tangent line, what are the x values, that's enough. So when you take the derivative and solve it, that's the work or justification required.
Because a horizontal is a 0, yeah.
And the last example, number 20, or last problem rather, find k so that this is true, right? Where that's a tangent line. So remember there were two equations we need. One was that they have to be equal to each other. So it was x squared minus kx equals 5x minus 4.
That's right.
And the other one was the derivative has to equal 5, right? Basically, take the derivative of both of them. Derivative of the function is 2x minus k. Derivative of 5x minus 4 is 5. This one's the easier one to solve for k, right? So it would be negative k equals negative 2x plus 5. So k equals 2x minus 5. Take that and substitute into the other one. So that's going to be x squared, right? I'm substituting for k. So I'm replacing the k with 2x minus 5. And go ahead and work that out. So it's x squared minus 2x squared plus 5x. Everybody see how I'm getting plus 5x?
Yes.
All right. 5x's go away, bring the 4 over, or not. Negative x squared plus 4 equals 0, or x squared minus 4 equals 0. So x equals plus or minus 2. That suggests that there may be two values of k that works. Okay? So we plug in positive 2 for here. I plug in positive 2 and negative 2. So k could be 2 times negative 2 minus 5, which is negative 9, or k equals 2 times positive 2 minus 5, which is negative 1. So k has two solutions. K equals negative 9, k equals negative 1.
What do you mean by it may have two different values? Can they be the same value if you plug them both in?
Yeah. But it wasn't, so it has two values. Yes?
It's kind of a trivial question, but what's the proper way to be like, hey, there are two different values? Like that?
What do you need?
Never mind, never mind. I see it.
I wasn't trying to avoid your question. I don't think you ever have to justify there's more than one answer.
Okay,
You just give them two answers.
okay.
You don't have to say there has to be two. Not that, so like if you have to do an intermediate value theorem problem, then they will say, why does it have two answers?
Okay.
But not in a problem like this.
Okay.
Okay? They're going to just give you some vague information and then ask you how many possible solutions are there?
Yeah, I was
Right, so
asking-
it won't be a problem in which where you actually find the two solutions.
Yeah.
Okay?
I was asking because in some questions, like I remember from last year, there you get multiple values, and some of them you just have to chop out, and so it would kind of be,
Right.
you know. I don't know if that would apply to this.
I'm going to stop the video.